So moving straight along now, I'm going to introduce you to the Faraday Institution. Again, there's some history here because in 2011, Susan Robertson was up on the stage receiving an award for a company called Oxford Catalyst. It's now called Sopholysis, and it's a gas to liquids company working on a huge project with Shell and British Airways to produce from waste fuel to put into those aircraft. So we're going to go straight in now. I'm going to introduce you to Professor Pam Thomas, who is the CEO, and Nick Smales, I think, will be with her, Head of Commercialization. Good morning to you both. I shall hand over to you. Welcome.
Thank you very much indeed, and that's a hard act to follow, but we'll do our best. So I'm just sharing the screen, I hope. This is always a hold your breath moment in these things. Yes, hopefully you can see that and you can hear us. So good morning, everybody, and it's really lovely to be here. Thank you very much for the invitation. So I'll just spend a couple of minutes introducing the Faraday Institution, and then I'll hand over to our Director of Commercial, who'll take you through a couple of case studies of how we are working to commercialize early stage research. So the Faraday Institution has been around since 2017 and running its research program since 2018. It's the UK's independent flagship organisation for application-inspired electrochemical energy storage research, which is a mouthful, so we're talking really battery science there. So we research in that field, and we do skills development and market analysis, and relevant to here, of course, early stage commercialization. And we have an industrially inspired mission with some industrial targets that were set out at the get-go for battery research and to drive excellence in that research and have innovation unleashed, which is the current government terminology, for the benefit of the UK. And our vision is to be a world-class science leader in this particular application area, battery science, and this would help position the UK to be a leader in the green industrial revolution, which we all know is so important. Our particular goals at the present time are to reduce the battery cost, weight and volume, to improve the performance, the reliability and resilience of the battery supply chain, amongst other things, enable integration into products and solutions, and very importantly, in doing this, develop whole life strategies to include recycling and reuse at the end of life of these batteries. And our model is that we convene as the National Strategic Programme in Battery Science, leading research scientists and industry partners in large-scale collaborative projects. And through these collaborations, which are right across the UK, from the south coast down here in Southampton, right up to St Andrews and Aberdeen on the north coast of Scotland, we convene these projects, convene the community, and undertake projects actively managed and guided by industry. So that's who we are. Our research portfolio at the present time has 3 strands. The 2 major strands, sorry, that's me moving my mouse. The 2 major strands are lithium ion. So what can we do with the current best technology? How do we move that even more to state of the art? And we have a range of projects on those. And Nick will particularly touch on multi-scale modeling in that stream. And then we have a stream that we call Beyond Lithium Ion. So this is looking at next generation technologies, in particular solid state batteries, which Nick will also touch on in his part. And we have lithium sulfur and sodium ion batteries in that stream as well. And we also run a number of characterization projects to develop new in operando characterization methods. So in talking to you today, what we want to get across to you is why the Faraday Institution is particularly fitted to do commercialization. It's to make the point that it's specifically part of our mission, so it's not something we do on the side, that we're the national programme in a strategic area of importance and shaped by industrial partners and independent of government, even though government funders, and gives a potential route, gives a route for potential investors into the most impactful UK electrochemical energy storage research, and is a shop window for the UK's top research on battery science. I will now pass to Nick because I know he has a lot to say in the remaining 10 minutes. So Nick, over to you.
Thank you, Pam. Good morning, everybody. I'm Nick Smales. I'm Head of Commercialisation at Faraday Institution. I have a background in venture capital, technology venture capital, and spinning companies out of industry and academia, and I've been working in clean energy for the last 15 years. I joined the Faraday Institution in April, and what I found particularly attractive is not only does it fund world-class research, but it takes its early-stage commercialization very seriously. And that is sort of demonstrated by the fact we invest or we deploy £30 million of funding into research every year, but on top of that we have a further £3 million for commercialization, and that manifests itself as a small team that focuses on intellectual property and discoveries and formal processes for commercialization, but also we can fund ad hoc projects that sort of start to address that gap between where sort of research funding finishes and private sector and industry funding begins. In terms of those formal processes, we have regular meetings with our projects every month where we talk about discoveries and identified IP and work out how the strategies for exploiting that IP. For those that we consider to be most attractive, we do our own analysis. We have this T-scan analysis, which you can see at the bottom of the slide here. The T-scan is an acronym. The T stands for the discoveries and the sort of timing of them. The S is the economic significance and plausible pathways to market. The C is all about competition. The A, we spend a lot of time on, it's the next step. So do we need to make a prototype, or is there a feasibility study that we need to get involved in? And we really work out the details of those and who to partner with and the commercial arrangements with those partners, and identify the resources we'll need in terms of equipment and facilities and personnel. And the end then is what funding we'll need to do that next step and where we'll get that funding from. So should we approach the public sector or corporate strategic investors, or indeed financial investors? And each of the T-scans sort of turns out as a 20 to 30 page piece of analysis on all of our projects across the portfolio. And if we could go to the next slide, Pam, please. And then we use that analysis to really prioritize our portfolio and work out which opportunities we're going to put most resource and effort into. And this is just one anonymized cut of what comes out of our T-scans, but there are probably 6 or 7 of these. And as I say, they help us prioritize what we're going to focus on. So I'm going to use the rest of this session to sort of focus on 3 of the opportunities we're focused upon. So again, could we move forward one slide, please, Pam? So as Pam said, the first thing I'm going to look at is solid-state batteries. Hopefully you're aware of solid-state batteries and the benefits that they sort of might deliver. It's increased energy density in the battery, which should sort of equate to a longer range in electric vehicles, faster charging and safer batteries compared to lithium-ion, the lithium-ion batteries we're using today. We talked to most of the automotive OEMs, and solid-state batteries are on all of their roadmaps to 2030. We have a £15 million research program that's looking at the design of solid-state batteries and especially the challenges around scale-up. And that's making good progress, in such good progress that we're now talking to 5 corporates and negotiating a consortium with them. Those corporates are across the supply chain. They include materials companies, equipment manufacturing companies, battery companies, and end users. And as I say, we are discussing the terms of a collaboration, which includes a significant investment, many tens of millions of pounds for a prototyping project, a 3-phase prototyping project over the next 4 years. And that project will certainly need more funding in phase 3, and we'd be looking to financial investors for that funding, and hence I thought it might be worth making you aware of this project because it might be something that you might wish to consider in the next 24 months as an investment opportunity. Can we move on again, Pam? So the next project I picked out was our multi-scale modelling project. It's an £18 million project. This is more about using computing power, software, data sets to address the sort of, and to reduce the time and cost of designing batteries and prototyping batteries. And I think we're looking at reducing time and cost by at least an order of magnitude. What we do is we look at sort of parameterization and algorithms and data sets around the characteristics of batteries like thermal performance or degradation. We have an open source platform where we work with our partners and it provides transparency and confidence to industry. And then sitting on that open source platform are a number of bespoke models which address industry requirements, and around those we can create sort of business models and companies. We already have a number of spin-out companies around this project, and we're currently incorporating another company. They're all revenue generating from day one, which is obviously quite attractive. And particularly this, in terms of its investment requirements and capital requirements, the multi-scale modelling opportunities are more akin to sort of a software opportunity than hardware opportunities that we see around batteries. So I thought it might be of interest and attractive to you, and hence I was picked it out. And can we finally move on to the third one, Pam? So lastly, but certainly not least, I've picked out recycling. There's no doubt that there's going to be tens of thousands of tons of electric batteries, electric vehicle batteries that are going to need recycling in the 2030s. But perhaps what's less understood is this market is beginning to grow now. As we build gigafactories and manufacture batteries within them, about 5 to 10% of the materials that go in come out as waste, and that waste is valuable. And if you can recycle it efficiently and reintroduce it into the manufacturing process, it's potentially all profit to the bottom line. So this is not only a big industry or a big sector in future decades, but it's started to grow today. The Faraday Institution has a big recycling project with 3 components. We look at how you understand the condition of batteries, so you know when to recycle them. Secondly, we're trying to build in recycling in the design phases, so pre-manufacturing of batteries, so when they do come to end of life and need recycling, they're easy to recycle. And then thirdly, we're looking at more sophisticated ways of recycling compared to the sort of current methods. So current methods, we sort of smash and shred materials and then add strong chemicals and heat to recycle. There's certainly opportunities for more sophisticated ways of doing that. There could be intelligent robots for the disassembly of batteries, or like this opportunity on the right of the slide, ultrasonic techniques for removing active materials from the metal substrates of batteries. So certainly opportunities for more sophisticated techniques, but the challenges are all around the techno-economics, and a large part of this program is focused on techno-economics, as with all of our programs. But we do see recycling as a significant opportunity going forward. So that's really all I was going to present. Can we go to the last slide, Pam? Those are 3 that I've picked out of the portfolio. There are more at various stages of maturity. Every single one of our opportunities will need investment from financial investors going forward, and I would hope that you would think of the Faraday Institution as a potential source of deals for you, and certainly we'll be very, very happy to hear from you in the coming weeks and months after this presentation. But thank you very much for giving us the opportunity to present the Faraday Institution to you. And on behalf of Pam and I, thank you very much. And I hope you have a very successful day at your conference.
Well, thank you very much. Thank you, Pam. Also, it's fascinating. There's a number of faces I can see here and heads nodding. So we will certainly be back to you. And congratulations on the work that you've done so far. Thank you very much for joining us. So now we move on to a 10-minute video from Cranfield. Cranfield, as you know, on the front page, has been a sponsor of ours for many years, and we have a very close relationship with them, traveling issues and that sort of thing. But I think we can move straight on to that now. Hannah, please. Thank you.
Here at Cranfield, we always like to see the bigger picture. As an exclusively postgraduate university, we take learning to new heights in technology and management. We award over 5% of the UK's engineering and technology PhDs every year. 81% of our research is classed as world-leading. Our academics find solutions to global challenges. Our graduates leave ready to launch into high-flying careers. That's why we rank in the UK top 5 for both commercial research and professional development. The bigger the question posed, the more innovative the solution required. That means collaboration between the brightest minds from academia and from industry working together. Everything we do is in partnership, whether it's with individuals, business, government, or industry. Those connections create opportunity. The opportunity to innovate. The opportunity to create. The opportunity to make a real impact. Our influence springs from the same bedrock that supports all our activities. Groundbreaking research applied in a practical way to global problems. It's our signature approach to learning that allows our people to make their mark, to build the kind of careers they want, and to become part of an alumni network which extends right around the world. So many brilliant minds in such close proximity creates a powerful flow of knowledge. Ideas are the currency our learners trade in. Our graduates are shining lights in leading thinking and policy making across the globe. Here at Cranfield, we like to aim high across technology and management. Our work reveals new horizons, and we create the leaders to get there.
That was our sponsor and partner, Cranfield University, 6th year now going strong. So very valued partnership there. We have a second video coming up from them now as well to learn a bit more about them.
You can't do anything without energy. The energy industry is going through a big transition, and it's to do with global warming.
Our work really addresses what we call the energy trilemma.
Where we used to be dependent on fossil fuels, there's a drive to transition across to renewables. So our priorities are really to look at how do we facilitate the change, how do we make fossil fuels as efficient as we can, how do we bring in new renewable technologies to replace those fossil fuels, and then how do we address some of the challenges of continued use of carbon. And we've got a limited amount of time to get those solutions into industry.
Digitization and digital data systems will enable us to be much more creative in designing market solutions that can support the availability of supply, but also create new business opportunities, new business models, so that we can use energy much more effectively.
Being better at using materials, being better at saving energy, being better at generating energy is absolutely vital for our economic wealth as well as human well-being.
I get to work with the very best minds, the established academics, but I also get to work with the new, fresh students coming in, so that changes the ways of thinking. We're here in energy to try and change the world.
There's a human and very important social aspect to all of this. As individuals, we have to understand how to use energy more effectively, both at the household, in industry and in transport. And currently, we lose roughly half of all the energy that we put into the system.
Our links to industry are multi-dimensional. They come to us and say, we have this problem, can you help us fix it?
Industry come and talk to us about projects because they want to work with students who are engaged, keen to understand real life problems and keen to be part of that problem solving.
Cranfield's connection to the industry was useful for the modules because they brought in guest lecturers from industry. I would say to a future student studying energy and power not to hesitate, because obviously climate change is a huge issue that everybody is looking into at the moment. There's something for everybody in the energy sector.
Thank you very much. Now we kick off with the first company presentation of the day. Michael Booth, CEO at Vertoro.
Good morning, everybody. A lot of people look at this picture and see a problem. In the previous movie, which was actually very interesting to see just before this presentation, you also saw images of oil refineries. As if the oil refineries themselves, the trillions in legacy assets in the fossil world, were actually the problem. We see an opportunity there, not a problem. The real problem is what's going into these trillions of legacy assets, not the steel. Fortunately, there's an abundance of sustainable and clean, cheap carbon, but it's solid. And you can imagine an oil industry, 150 years working nearly exclusively with liquid inputs, will have a difficult time coping with anything solid put on their doorstep. And this is where we come in as Vertoro. It's actually a very simple idea, very simple vision. There's billions of metric tons and cheap, sustainable carbon, solid. On the other side of the value chain, there's trillions in legacy assets in want of a lower carbon footprint. And all we do is go from the solid biomass through a simple process, which I'll explain later, into a liquid oil that can be fed directly in existing infrastructure and going into these existing trillions in legacy assets. I always like to compare, especially in the morning, especially on Friday mornings, our technology to making an espresso. Our technology is thermal Sopholysis. Thermal Sopholysis is the technology used to make coffee. And just imagine a coffee machine. Instead of putting in water, we put in a solvent, typically sustainable methanol, e-methanol, or biomethanol. Instead of coffee beans, we put in this cheap, abundant, sustainable carbon, like sawdust, bagasse, or even coffee grounds. We have to turn up the thermostat a little. 90 degrees won't get us to where we want to go. So we have to heat it up a bit to about 180 degrees Celsius. But if these were the only modifications made to the coffee machine, you could run our recipe on it very easily. So it's very easy to scale. As with making coffee, we have a solid residue. In our case, the solid residue is cellulose. Cellulose that can be used to make any manner of high-value applications like cellulosic ethanol or paper. We really want to set up our platform we call Goldilocks because we think we're doing it just right, like in the fairy tale. So we call our oil Goldilocks. On the feedstock side, we can feed in biorefinery lignins or lignin effluent streams from the paper industry, but also, as I just said, lignocellulose, or any type of terrestrial biomass. We run it through our coffee machine, get the oil, and then we have a range of applications for this oil, just like fossil oil has a plethora of applications. We can go directly into plastics like polyurethane, phenolic resins, thermoplastics as well. We can also use the oil to feed into existing oil refineries at the cracker level, and then they break down our oil to the smallest Lego blocks and then rebuild to whatever the oil company would like to produce in terms of chemicals and materials or fuels. But our go-to market is marine fuel, because this sector can use our coffee directly without any changes or downstream processing of the product. The marine fuel market accounts for about 2% of global CO2 emissions and is now subject to ever more stringent legislation. Just a few weeks ago, or last week actually, I believe, the EU announced a sweeping set of reforms pertaining to the whole carbon trading system, which will now for the first time also include aviation and shipping. So the whole sector has been turned upside down and is scrambling to find solutions. Needless to say, it's a huge market, over 120 billion euros in 2019, and it's still growing. And within this huge market, we of course have to find our niche. And our niche is deep sea container shipping. Why? It's the largest market segment in shipping. Within the shipping sector, it's also the one that is growing quickest. The sector is able to cope with higher fuel prices, more on that later. And I just put here the top 3 shipping companies in terms of fleet. So it's Maersk, MSC, and CMA being the largest ones. Maersk recently in their 2020 sustainability report did an analysis. They did some math. What if, on account of fuels being more sustainable and more expensive by proxy, what would that mean if we doubled the fuel price? That means that the shipping rate to ship a container from A to B would increase by 20%. Now, what does that mean? That means for a pair of sneakers, a 6-cent increase in price. For a computer, 60 cents. For a banana, 1 cent. And you see the relative percentages below. And this is unique, because if you think about aviation, I flew here on Transavia from Holland. If Transavia doubled the fuel price, or had to pay somebody double for the fuel price, my ticket wouldn't increase by 0.001%. It would probably increase by 50+%. And it's the same for automotive. The container shipping market in that respect is unique because every container contains possibly millions in high-value goods. So it doesn't really matter in terms of total cost what the shipping from A to B actually contributes. So it's a unique set of circumstances. Of course, there's competition out there, and I'd like to take you through them one by one. Fortunately for us, Maersk was the largest of the 3, did our competition analysis for us. We're the 3rd fuel on the list. What they're using now is called UCO, used cooking oil methyl esters to be precise. This is made from used cooking oil. It's sold by companies like Shell to Maersk. The big drawback there is availability. So it's drop-in, perfectly miscible with everything fossil, but there's only so much McDonald's we can eat, and then the used cooking oil is depleted. So there's an availability, scarcity there, which is reflected also in the price. The second one, and I think this is the one they're really banking on the most, is methanol. Remember, methanol is the our water for the coffee machine, so what we put in the coffee machine. Methanol has already established itself as a commercial shipping fuel. There's all manner of ships already sailing on methanol today. But this is fossil methanol, and Maersk wants to leapfrog to sustainable methanol, produced either by electricity, so-called e-methanol, so renewable electricity, or biomethanol produced from residual biomass streams. The advantage for this is that it's already established. Disadvantage will be lack of availability to date. So even though the technologies are there to do it in principle, the installed capacity is still very low. And also there's some worries about price. And then comes our fuel. We're the only company in the world producing this type of coffee. Strangely enough, Maersk was very interested in it. Lignin fuels, as they identify, so remember, our coffee contains only part of the biomass. The lignin part, the cellulose, is in the waste bin. We go from that to ethanol or paper, for instance. So these lignin fuels, blends, lignin and methanol, are seen by Maersk as being the most price competitive, the one that could really someday reach price parity with fossil benchmarks. Of course, they note, and that's why I'm standing here to pitch for money to scale up. It's still in a development stage, so we need to ramp up production. We need to jump through all the regulatory hoops. In fact, you need something like 10,000 metric tons in order to get the fuel fully certified, which means you need a commercial scale plant in order to produce enough fuel just to get the regulatory approval. The fourth fuel they're betting on is ammonia, and ammonia is carbon-free. So this is seen as like the holy grail. If we could make ammonia, then there's no carbon in the fuel, no carbon emissions from the ship. You can make ammonia, green ammonia at least, from electricity, from renewable electricity, but there's some safety and toxicity issues there. Also cost. And just to give you an idea about the size of this market and this market niche, and looking only at Maersk, having just 1/4 of Maersk's business, so assuming they split their future need amongst these four fuels, will give us over 2 billion euros in annual recurring revenue. And remember, this is just one shipping company in a shipping market, and only one of the applications we're developing for our oil. Looking to our management team, so the founders, myself, and Panos were engineers, so technical, academics. We brought in people from industry, our target markets. Tim is an energy economics expert, previously at Aramco, oil company, the largest oil company in the world. David was previously at Maersk, in charge of all their biofuel projects. Maersk, the largest shipping company in the world. So we feel that with the strengthening of our team from these sectors, we have a good mix of people that actually know how the world works, and us being technical academic people. Coming to my last slide, if we look to our roadmap, we started in 2017 as a university spin-off, basically. Since then, we raised about 2 million euros in seed capital, equity, and non-dilutives. We've been operating successfully a pilot plant in the south of the Netherlands since 2019. When I was here in October, the previous edition, I was pitching for the A round. I can now say we're wrapping up the A round. We signed a term sheet 4 months ago with 3 financial VCs and a strategic. The only thing I can say about that is that a condition precedent will be that there's a guaranteed offtake agreement for the first 3 plants included before we can close. We're now wrapping up all the transaction documents. We expect to bring the formal news outside in a matter of weeks. So today I'm pitching for the B round. The B round is to construct this first 10,000 ton commercial scale plant. We already received a 2 million euro grant from the Port of Rotterdam to get us landed over there. The Port of Rotterdam is also for Maersk one of their strategic ports. Beyond that, beyond 10,000 tons, the technology will scale in a modular way. So If we go up to 200,000 tons, it's just 20 of these commercial scale units put in parallel. And with that, I'd like to wrap up and entertain any questions you might have. And thank you for your attention.
Thank you very much, Michael. If we may ask, again, there is a microphone available here, so please do, any questions you may wish to ask, please come up front just so we can hear it on the online still. Just here. Thank you.
Michael, have you ever used trees?
We have not used trees. We have used sawdust from the wood processing industry.
And the sawdust is already gathered in from a lumber, a sawmill?
Yeah, we use third parties for that. That will also, once we're at scale, take a part of the capex. So they'll dry and mill the sawdust on site to spec, so that we have a minimum number of truck movements to the port. It's very strict, rather than nitric oxide limits. So we really have to have the biomass already as condensed and high value as possible coming in.
What about crop residues?
It's possible. So we've used bagasse mainly. We have a partner in India who's in cellulosic ethanol space that from the sugar to ethanol industry, there's a lot of bagasse left over. That was actually the picture I showed with showing the biomass of bagasse. So bagasse works. We also worked with corn stover. In fact, we can use any type of biomass. The only difference that we have is the ratio in products coming out. So agricultural wastes typically have low lignin content, high cellulose content. And woody biomass is more the other way around.
Last question is the 200 degrees Celsius, is that the optimal, or just that's variable depending on the feedstock?
Well, I guess the sweet spot is around 180. If we go a lot higher than that, we actually start to do chemistry, and then we crack the lignin. And for a lot of our high value markets, we want the lignin to be as native as possible, because lignin is a natural antioxidant. So we're selling it into feed markets now. It's a natural UV stabilizer, selling it in sunscreen markets. And if you increase the temperature too much, your yields might go up, but then the quality of the lignin goes down, and we would have difficulty going into these higher value markets.
Okay, thank you.
Thank you, sir.
Anyone else, please do feel free to come forward. Just a quick question as well, referring to the booklet. You've touched upon your outputs being pre-sold to a high extent. Would you be able to just tell us more about that?
Only that it's pre-sold, and that the selling is part of the transaction documents of the A round. I'm not at liberty to say more than that, but you may surmise something.
Thank you very much. That's perfectly fine. Right. Unless there's any more questions, thank you very much, Michael, and we shall move to the next presentation. Up next is IPG and Toby Gill. Thank you.
Hello. So, that's not working. There we go. No, too far. Okay, there we are. So I'm Toby Gill, CEO of IPG, and today I'm excited to talk to you all about how we at IPG are replacing the diesel generator. First question, why are we doing that? We're doing that because in these difficult to decarbonize industries, including the distributed power market, the projections are still saying that we're going to be using a lot of diesel. And in particular, it might be surprising to people just how much of this market is going to be supplied by the diesel generator, despite all our predictions. This dependency arises from these difficult to decarbonize sectors because at its core, the diesel generator provides low-cost, dispatchable power with essentially zero risk in power supply, And therefore, businesses have the knowledge that they can get the power they need exactly when and where they need it. One of these difficult to decarbonize sectors is the construction industry, where owing to the difficulties in rapidly deploying grid connections and the lack of space for on-site wind and solar, means that the power requirements for this industry are still projected to be dependent on diesel generators for a long time to come. In the UK alone, as much as £6 billion a year will continue to be spent on diesel for on-site power generation in just this industry. Furthermore, with the UK government set to increase the taxation on red diesel for power generation on site, the value that can be created from this replacement to the diesel generator is greater than ever. The roadmap to decarbonising this kind of power is very simple on paper, right? We use more biofuels, other renewable fuels, in particular green hydrogen, and we use those fuels with technologies that can produce power from them without producing harmful pollutant emissions. But with technologies that can operate on these fuels without producing pollution already in the market, we have to ask ourselves, why are the projections for diesel still so high? Now, clearly, at the global scale, this is a very complex issue, but for these companies that are making decisions about what to buy for their power generation, we need to understand what their mindset is. When it comes to picking a generator, the two most important factors, despite our green ambitions, are cost and security in power supply. Renewably fueled generators in the market today are not only expensive, but they're dependent and designed on specific renewable fuels. And what this means is that they're dependent on a specific and uncertain renewable fuel market. So in the near, mid, and even long-term future, when companies are making a decision about what generator they want to buy, all too often they will pick a diesel generator. So what IPG have created is a product that by design is both low cost and secure. So how have we done that? What we've done is we've overcome this uncertainty in the renewable fuel market by using our breakthrough flameless combustion technology that enables us to generate power on any fuel. And what this means is that businesses can select a single product that can use the readily available lower carbon fuels of today and switch to hydrogen and biofuels and other fuels as they become available. Crucially as well, it's that fuel flexibility that is going to help drive the demand for those renewable fuels. Put very simply, the IPG flameless generator is a cleaner, cheaper, future-proof alternative to the diesel generator. It's cleaner because through our flameless combustion technology, we eliminate pollutant emissions that also have a CO2 equivalency benefit. It's cheaper because with our high-temperature ceramics and waste heat recovery, we're able to deliver higher efficiencies that reduce fuel costs. But most importantly, it's future-proof. Because by operating on any fuel, businesses can invest in a single product without risk to their power supply and without risk to that asset becoming redundant tomorrow. IPG was founded in 2016 and since then has attracted and benefits from the support of some real key experts across the energy and clean tech space. This includes Ian Marchant, whose career spans executive roles in Scottish and Southern Energy, Thames Water, and Aggreko. Nigel Ellis brings decades of on-the-ground experience into deploying energy innovations into the energy sector. Volker Schult has wide-reaching industry knowledge that really helps us focus and guide our route to market. And finally, Tom Whitehouse helps provide us with the key insights we need to plan our future funding requirements. This deep industry expertise couples with the entrepreneurial and technical expertise of our leadership team that we really feel have the skill set and experience required to bring this product to market. Since that founding, IPG has gone through 3 core phases of development. The first of this was the initial design and conception work of the technological innovations that underpin our product. But before we went forward to build prototypes and spend lots of money, what we needed to do is we needed to prove to ourselves that there was a route forward to making this product cost competitively. The highest uncertainty in that was our high temperature ceramics, And so what we did is we spent a bunch of time testing and building an end-to-end supply chain for those ceramic components. So with a clear roadmap to making this product at a price that is competitive, we're then able to go forward and prove these innovations with prototypes, proof of concepts, and securing patents on all of them, which are now fully granted in the UK and undergoing PCT filings in other jurisdictions. This year, we moved beyond this sort of phase of purely technological innovation and deployed our first project with Highways England, securing £1 million from them, and they are the UK company mandated by the government to look after the motorways, service stations, and the rider strategic road network. What we're doing in this project is we're deploying our first full-scale 100 kilowatt prototype. Now, beyond the construction application that I spoke about at the beginning of the presentation, the use case that Highways England are most interested in is using our product for providing off-grid power to EV charging in locations where there's either high use or remote, and therefore their grid capacities are constrained. This basically puts IPG in a really good position. We've proven our technology, we're in the process of delivering our first project with a paying customer, and this now gives us the confidence to begin to move forward into the commercialization phase of our business. What we have to do now is plot this route forward to becoming profitable. To do that, we have a clear target. We need to be selling around 250 units a year, generating around £37.5 million in revenues, and we need to do this in 2026. The way that we're going to do this begins with undertaking our first commercial pilot trial of our minimal viable product towards the end of next year. We'll then enter into a phase of 18-month longer-term commercial trials with customers to build hours on the clock to give them the confidence in the low-cost, secure, and environmental benefits of our product. This is so that we can build the order book for the first low-volume manufacturing run in 2025 of 100 units a year. This development roadmap is designed to align IPG's product development to the pain points and therefore demand in our target markets. So we talked about the construction industry and how this change in diesel taxation in the UK is really starting to drive companies to understand how they can accelerate their transition away from diesel generators. And so what we want to be doing is targeting these customers to begin these pilot trials, to build their confidence in our product and get the order book for those first 100 units. We also know from that prototype project with Highways England that there will be demand for this in EV charging. But when we look at that kind of future exponential adoption of electric vehicles, this pain point is not quite being felt today, but is going to be present in 2025, 2026, and that's exactly the right time, therefore, for us to bring the same product into that market. So, clearly, if we are going to have a valuable product for our customers, it's got to deliver some kind of value. Now, putting the environmental benefits and the energy security benefits to one side, that value has to come down to base economics. With these changes in red diesel taxation, a 100 kilowatt diesel generator will have a cost profile that looks something like this over the coming years. Now, at our low volume manufacturing point, despite the higher unit cost, the higher efficiencies of the IPG flameless generator mean that we can deliver lower cost or equivalently cost power from readily available low carbon fuels or biofuels and even hydrogen. And so combining that economic benefit with the environmental benefits and the energy security, we really feel that we've got a strong ability to drive demand for those first 100 and 250 units in 2025 and beyond. Obviously, as a relatively early stage company, what IPG needs to be doing is building and securing the supply chain for the product, as well as securing the initial sales channels for it as well. And indeed, this is where we've been focusing much of our attention and will continue to do so as we progress through commercialization and these pilot trials. In that model, obviously, IPG will receive revenues as a percentage of sales, and it's that that underpins our target of 250 units a year to achieve profitability. Yet, there are other ways in which IPG could secure greater revenues from this value chain. Throughout the distributed power market, energy as a service models are becoming ever more attractive. For customers, it's simple. The service providers offer them a simple, low-cost, secure service. For the service providers themselves, greater revenues, greater profits can be secured. In the case of IPG, our fuel flexibility offers up some interesting potential here. We can enter into fuel arbitrage far more easily, and because our product can operate on any fuel, in this future fragmented renewable fuels market, we will be able to offer energy as a service at a far lower capital intensity because we won't have to maintain multiple assets for multiple fuels across markets. As we move forward through these commercialization phases and the early pilot trials, we'll be working with our customers to understand the best balance between kit sales and energy as a service projects. Clearly, moving beyond those initial sales targets and that initial point of profitability, the growth rate of IPG is going to absolutely be dictated by our products improving economics. What I'd already shown on one of the previous slides is numbers projected for the beginning of our low volume manufacturing, where a sales price of £150,000 per unit is underpinned by manufacturing costs of around £100,000. In partnership with our existing supply chain, we've worked to create a roadmap using alternative but proven ceramic manufacturing methods that can drive this down to about £40,000 per unit at around 1,000 units or more a year. And so when we look forward to that stage of our company, you really get the sense that our profitability is not going to be limited by our production cost, but just our ability to manufacture these units. That brings me to why am I here today? So I'm here for 3 reasons. Number 1, I would like to start speaking to those funding organizations that could have the interest in participating in our future funding requirements. We're keen to start talking to customers that think that we can help them replace their diesel generator and explore participation in our pilot trials. And finally, I'm here to secure or look at securing an additional £1 million to close out our £3 million fundraise from early stage investors that were due to close at the end of October this year. The product that we spent the last 4 years, around £6 million developing, is a true breakthrough in power generation technology. A statement we feel is supported by the strong commercial traction we have with public companies, government agencies, and other environmental innovators. We can do this with our flameless combustion technology, allowing companies to transition away from diesel in a way that is very low risk for them. And finally, as I said, we're looking to raise that additional £1 million capital. And so what we're looking for is to find investors who believe in our mission and believe, as we do, that replacing the diesel generator is going to be a valuable way of combating climate change. Thank you very much.
Perhaps I'll start with a question. Thank you very much, Toby, first of all. Please, could you explain a bit further about the advantages and disadvantages that your technology has to fuel cells, please?
Sure. So I think first and foremost, it really comes down to this fuel flexibility, right? I think fuel cells are great in principle if you have an absolute secure energy supply and you know that you're going to be able to get that hydrogen at the price that you know you need and the abundancy that you need. But if you don't, then it becomes a very risky problem. Moreover, there are challenges with the operational reliability of fuel cells. Our technology is a gas turbine at the end of the day, which is a far more proven and reliable technology. So I think really what it comes down to is, can you provide the best levelized cost of energy on the future renewable fuels? We think we've got the best roadmap to doing that.
Thank you very much. We have a question coming up.
Hello, Yvette Go, Capricorn Partners. Thank you for the presentation. I have a question. Could you say something about, have you done freedom to operate check? Because there are some sort of burner technologies and there are some other combustion technologies in this flameless area.
Sure. Yeah, no, so we have done a freedom to operate check and we have cleared and granted patents on all our innovations, so we know that we're okay.
Mm-hmm. Okay, thank you.
Could I also just ask as well, so you're talking about the pilot that you're doing with English Highways as well.
Yeah.
Could you explain a bit more on both this partnership and future partnerships that are in the pipeline?
Sure. So Highways England, we came to them and sort of said that we understand that you're trying to prepare the strategic road network for this adoption of electric vehicles, and you're being mandated by the government to ensure that there's ultra-fast charging points all over the place. And we sort of asked them the simple question of, do you think you're actually going to be able to do that with the grid? Or on-site wind and solar? And the answer they came back with was, no, we don't think we can do that. Now, what they didn't have was a clear alternative, right? What no one wants to see is diesel generators being lumped down to charge electric vehicles. And they made the decision that other technologies, such as fuel cells, were not going to provide this for them. And so that's why they put up £1 million to help us prove this out for them. And what we're looking forward to do is growing on that relationship as we move through over the next few months and years, so we can start putting these actually in the field and trialing that on a much larger scale. One of the other companies that people may have seen on the slide is Aggreko. So Aggreko, one of the largest, if not the largest, temporary power provider in the world. They have 10,000 megawatts of diesel generators across the globe. And I'm sure it doesn't take a genius to put two and two together that they need to find alternatives.
So just a quick follow-up on that as well. The markets that you're interested in then, thinking also geographically, could you expand on that?
Sure, yeah. So initially, as we sort of said in this presentation, for these kind of pilot trials in the first couple of years, we think that finding the locations where fuel costs are going up and there's that sort of incentive to really transition away, i.e. Europe and the UK, are going to be key to those pilot trials. But clearly, if we're talking about where diesel generators are going to predominantly be used going forward, and actually you're looking at sort of Africa, South and Southeast Asia, and that's really therefore going to be important for us to move out in that direction. And that's also useful for us because these are the markets where there's going to be a greater diversity in renewable fuels, due to the different kind of feedstocks and some of the interesting things other guys here are doing, right?
Okay, thank you very much. Any other questions?
There was another question that popped up. I know you're in a research, or sort of more in the research phase, but could you say something about how you envision your road to market?
Yeah, sure. So I think at the moment, it's looking very much like we need to secure the kind of orders books from a large, or one or two or three large customers, and some of those are on the board that we're already in early stage discussions with. Because to get the unit cost down, we need to hit that first 100 units a year production run. And so we need to find people who have that order book, right? And so that's what this pilot trial phase is all about, right? It's just saying, building the confidence for those customers that we've got lined up to say, look, you now believe in this low-cost benefit of our product.
Yes, and when you say large customers, can you say something more as a certain segments? Or?
Sure, so in segments, I think, like we said, so we're initially looking at the construction sector and the EV charging sector, because in Europe, where we see that's where the first pain points are really going to be. But going forward, you're looking at anywhere else that a diesel generator is used. Now, I think more specific, which is everything, right? But I think more specifically, we need to look at where the renewable fuels are available and where they're diverse, because that's going to really play into our unique points. And I think what you're really looking at there is then these kind of remote mini grids and manufacturing facilities that have use of this. Mining, we're also talking to mining companies about needing to support the wind and solar ambitions they have there as well. So I think at the moment, we know what we need to identify in these markets, which is these pain points around fuel availability, but we're still quite open to which exactly of those markets it needs to be.
Okay, thank you.
No worries.
Thank you very much, Toby.
Thank you.
We now move on with Jamie Goldring, CEO of Circularity.
Thanks very much, Hannah, and thanks very much to the Innovator Capital team for kindly hosting this and putting this incredible event together. So I founded Circularity when the pandemic hit because I realized that there's so much incredible sustainable invention and innovation that's coming through the pipeline, but unless we graduate from the linear economy with this take a resource, make a something, and then waste the product from that, then we're going to forever be stuck in this greenwashing loop, which doesn't graduate beyond the current state. So circularity is a new dynamic. It's the ability to decouple economic growth from resource utilization. And indeed, it should be the mission of every organization on the planet to have a circular agenda in order to scale sustainability, drive this invention and innovation, and create a new dynamic which will decouple the relationship between resource utilization and economic growth. I just wanted to start with why I think, as of now, we've reached what we call the circular tipping point, and it's based very much on our history, which actually, when you look at it, sounds like the ravings of a lunatic. So the Industrial Revolution created the linear economy, where we're taking resources and our ancestors are having a jolly old time plundering the planet. But the problem is, by 1970, we devastated 60% of global ecosystems and saved their environmental renaissance of the 80s and 90s. Apparel production, our target markets, doubled from 50 to 100 billion units per year, creating 10% of greenhouse gases, with 90% of that apparel disposed of or incinerated. As of 2021, we now have just 9% of our global carbon budget remaining. And at the end of this decade, we welcome an additional 3 billion consumers, now consuming 2 planet Earths to the one we do have, demanding 40% more resources like food and energy, clothes and cars. And by the 2040s, since I was born in 1980, we're now extracting 170 billion of tons of material from the planet, now pretty quickly using 3 planet Earths to the ones we got. Something doesn't really add up with the waste, with the maths. 70% more waste, and according to Carney and Gates and others, we're going to have a climate death rate similar to that of COVID-19. We're on course for 2 degrees hotter now. Mediterranean Sahara is the least of our worries, with 1/3 of living species extinct, putting us on course for a 2100 3-degree apocalypse, triggering actually something called a carbon feedback loop, where plants and oceans start to emit carbon rather than absorb them. And so it's very much because we only have one Earth, not 3, it's the purpose-driven mission of why we founded Circularity, to scale sustainability, to solve these challenges by creating a digital infrastructure to bring these pieces together to meet and master these emergent challenges. So that's the big why. We've put together really kind of a crack team of experts in technology, retail, and brands. Myself, I used to work for Salesforce. In fact, if you've ever bought anything outside of Amazon, you've probably interacted with some of the technology I might have launched over the last 12 years, whether it's an e-commerce platform, an order being routed to you, or the 5 stars on the product page in terms of reviews. My CTO and co-founder, Jazz, has worked with the likes of IBM and SAP, clunky, heavy enterprise-class systems. Graham Broomfield's an eBay executive that then pivoted to retail and held senior roles, including LK Bennett, helped scale the business online with Linda Bennett herself. And finally, Mehdi, who launched an OMS cloud product to Series B, raising $50 million and garnering some huge clients from sort of Chanel and Richemont. Our non-executive board is made of really the kind of cross-section of best of breed of consultancy, retail, and brands. Hash Ladar helped scale Farfetch in his early days before becoming CEO of Oasis warehouse Karen Millen. Dr. Melissa Barrett ran the sustainability practice of Accenture for a decade. And Don Brown is actually Ted Baker. He actually joined the founding team with Ray Kelvin and built their production facility for over 31 years. And Lynn Everson helped to launch TU Clothing through Sainsbury's, George through Asda, and then held senior retail positions at brands like Swarovski before heading up Alvarez and Marsal. They're kind of like a boutique Accenture with some major clients. Our advisory board, from the author Ken Webster to one of the most connected wholesale professionals in the world, Ricky Green, who knows pretty much everyone, through to Phil Clark, who's running point on our raise, and he's the commercial director at Ted Baker, helping to raise £178 million a couple of years ago to pull them back into the black. Another senior executive, Louise Salt, who used to work at TFG, including Whistles, the Forshini Group, who now heads things up at Crew. And finally, Francesca Burrick, who's part of the Ellen MacArthur Foundation, as well as Body Shop and Accenture formatively to that. So the reason really why we're starting with apparel is because the heat map is so significant and the waste map across their entire product life cycle, from design and sourcing, processing and manufacturing, through to the use and reuse phase, with consumers having absolutely no incentive apart from to perhaps take it to a charity shop if they're feeling charitable. But more often than not, it goes in the bin, it goes to landfill, it goes to disposal. In fact, since I've been talking, there's been about 50,000 units that have sadly had that fate. Pivoting to the circular economy has tremendous benefit, not just from revenue initiatives, premiumization with higher pricing power for building products that are durable and last longer, but also cracking into new markets, attracting new consumers, and scaling new circular business models with tremendous new horizons to generate growth for organizations, as well as bringing down your entire cost base by reusing resources, by sourcing and smarting more efficiently and more effectively. And actually, McKinsey have gone a step further and said that those that pivot to this model within the next 10 years will have a 4.3% compound annual growth rate increase versus those that arrogantly decide to go about business as usual will have a minus 3.7% growth rate. And that, according to my friends, is actually incredibly conservative. So I want to talk about our platform, and we're actually going to focus on the bottom half, if you can see that, use and reuse, for reasons I'll come on to explain, because this has to be driven by the power and the pace of the consumer, and I'm going to show you how we're going to go and do it. So let's pop over to Paris and have a look at the life of a T-shirt. And so, apologies, one of the videos doesn't load. So while that's clicking about, fundamentally, we're going to follow our protagonist, T. And T is your favorite T-shirt, fundamentally. And here he is on his journey. Now, T is a happy-go-lucky chappy, very excited and excitable, perhaps because he's been on holiday for his entire life. He's been to more countries than most across his raw material, his processing days, through the manufacturer. He's been to India, possibly China, West Texas, Pakistan, Morocco, Turkey. He's been absolutely everywhere. But it's us that are paying for T's holidays and his exuberance, with 2.5 years worth of drinking water and 3 pretty grumpy-looking baby elephants worth of CO2 equivalent, which is like 5 business class trip return to New York. So T and his 1 trillion, by the way, now pals, have a 90% chance of lasting less than 2 years or being burned or buried to death, which is pretty disconcerting, I think, for anyone. Does any of this have any chance of changing anytime soon? Absolutely not, because T is from the House of Fashion. The House of Fashion has many challenges, but there are 4 in particular which they cannot ever seem to get past. And the first is technology. Their systems were built 20 years ago. None of them were designed for sustainability, let alone the circular economy, and all their systems are out of date. Secondly, commercialization. It's incredibly difficult and not very profitable for an individual brand to scale circular business models. On top of that, there's a tremendous wave of compliance about to come in, from extended producer responsibility and other acts I'll come on to talk about. And finally, collaboration in itself. If you think about it, shareholders, stakeholders, and consumers are totally divergent. They all want different things, and there's no central well of information to bring them all together. And absolutely in the boardroom, everyone's very happy to talk about their revenue, but can anyone talk about the environmental intensity of your impact in economic terms? Very, very, very few can. So if we sort of widen out and look at these issues in their holistic term, all the merchandising and back office systems were designed to make, waste. That's the absolute reality. They're all legacy. They're IBM, 2002, Microsoft olden days. All the internal processes are siloed with spreadsheets and Excel. People don't talk to each other. And actually all the environmental data is 7 years out of date. And the social data is non-existent. And on top of that, what do? They just greenwash. They just use words like ethical and sustainable, and they pretend, and they trick consumers. But consumers are getting wise to it. And fundamentally, on top of new circular business models being incredibly hard to scale, on top of that, they're completely decoupled from sales channels. I don't know if many of you have been onto a product page and said anything apart from the word ethical or sustainability. There's no evidence. And there's also no consumer incentive for me to do anything but perhaps bin this jacket when I'm finished with it. From compliance, the drumbeat is increasing. The overstated claims on balance sheets and through annual reports is creating a huge critical legal risk issue for these organizations. Extended producer responsibility is coming on, or total product liability, where you have to pay for the end of use of whatever happens to the life of this jacket. You've all heard of the EU Circular Economy Action Plan. There's landmark legislation coming in the US and the UK and other countries. And on top of that, no one's collaborating. The stakeholders are obsessed with what's called input margin. It has to be 80% no matter what happens. So fundamentally, stakeholders are wanting to tell shareholders where the threads and fibers come from, but they've got no idea. Consumers are marching the drumbeat to try and increase the capacity for transparency, but it's still not there. So they're switching to other brands. There's total divergence. There's no system of record. Where do you keep all this data? It doesn't exist. It's kind of imaginary. That's why you can't really link business operations to sustainability goals. And so what this really means in pure McKinsey terms is you're looking at a 60% write-down of EBITDA over the next decade if you don't get this right. So what we're very plainly doing at Circularity is de-risking many of these issues for our client and giving our friend T here kind of like a magical tool, like a weapon within our platform to go about and meet and master these issues in a way which has never been done before. You know, obviously, who wouldn't be happy about that? And we're helping to solve the technology issue by creating a whole new environment built on Google, which I'll come on to, helping to scale the commercial model, to drive real change by the cadence of the consumer, and helping to solve the system of record and certain aspects of compliance. And I just want to take you on a little journey of T through our platform to show you how we do that. Let's go back one, apologies. So this is our platform, and I'll come on to talk about it. But fundamentally, T, in his very sort of grumpy way, is sort of wondering, what is our platform going to do? How does this lightsaber work? Like, I begin with the Force, what do I do with it? So fundamentally, we solve the technology challenge by building everything in Google. And so Mac architecture, which is microservices, APIs, right the way through to cloud native. And we use our compliance data to really kind of create collaboration by mapping together the entire genome of his data, which I'll come on to talk about. Through the use phase, we're able to solve commercialization through injecting this into the front-end product page, as well as to really, truly kind of understand how to bring that to life through an app, which I'll talk about. And finally, through compliance, we can track extended producer responsibility. Turn the sound off. So what does T do? So T's got a 90% chance of incineration being sent to landfill in India in under 2 years. So the first module is C, which is our implementation arm, which uses multilingual chatbots, geospatial mapping and technology, algorithms and AI calculations to create what's called an economic environmental profit and loss. And now they enable us to map the whole genome of T in a way which has never been done before, with entire transparency and traceability, and then take this sustainability data and inject it into the use phase of the platform. So from farm to factory to use and reuse stats, we can bring this to life through the product page. So now as T is ready to go to market after his fantastic series of holidays, you see everything else you'd expect to see on an e-commerce page. But on top of that, we can actually have a look at the farm he came from, either as an individual farm or a municipal level. And we can go a stage further and see, what is the carbon, water, and biodiversity loss of his source of origin. Then via our, and we give it a traffic light system, so the consumer can very easily see, sort of good, medium, medium. And actually, it doesn't matter if it's bad. You just start the conversation with the consumer to kick things off. And from a factory perspective, where was T made? Well, you can send out the multilingual chatbots, gather environmental and social data, and see there's, the gender split, $313, 2% above average age, wage, 4% above 4 stars of health and safety. And you can do an Uber-style tip a worker between 5 and 15%, which is really bring things together. You can also very plainly show consumers, the amount of drinking waters and emissions saved by buying him, the cost in terms of resources, like a couple of pounds for carbon, etc., as well as the CO2 equivalents. But you can also offset as well, like add £2 or £3 to this order to offset the impact of T and his exuberance. And finally, and quite critically, we bring to life the use phase by bringing together the 4 major channels, which is resale. So I can see that even though I'm buying this for 100, I could maybe make 50 back. I could probably get 300 points of Avios for repairing it, maybe make a tenner a year through renting it out, or I could just take it back to store when I'm done and get a 20% return deposit on my next purchase. That will then prompt you to be able to download the app, which you can also just scan a QR code and have the same experience, which is about to pop up, which we call our reuse module. So reuse is really important, and this is where we get the real heart of the consumer. We can interact, and I can talk to this jacket via voice AI. The jacket can chat back to me and also upsell and recommend information, give me social environmental data as well as washing instructions, and really create an emotional connection with the consumer and ask consumer questions like, why did you buy me? Was it for smartwear? Was it for casual? What other kind of clothes do you like? And you can kind of build a relationship with T, and then we can actually retarget you with products you actually want because you buy sustainable, we know you like organic cotton, that's actually kind of relevant via an upsell. And then when I'm ready to take T back in store, I can just have the QR code scanned and have 20% uplift. So we're driving not only upsell opportunities, but second life options. But T also recommends a nice sustainable pair of cotton jeans called Jay. There he is. And so maybe after a year, 18 months, we can send messages. Do you want to sell it to ThreadUp? Do you want to sell it to Depop? Do you want to go to Poshmark? We bring a marketplace of resale options where we take, like Google, an affiliate link tracking percentage of sending people across to there. Pull up a map of your local repair stations so you're geolocated. Go to Rent the One Runway, perhaps. But fundamentally, the stats we've seen is that not only are we turning consumers to custodians of product, we're increasing the lifespan of this T-shirt by 2 to 10 times, and perhaps being able to recover as much as 45 to 70% of materials, with 20-point uptick in conversion, 20% increase in revenue per product, 25% increase in LTV. We've zeroed out this bit because we give T 5 live instead of 1, with 5 opportunities and resale and revenue opportunities, and 5 lives for T via Circularity. Just want to dive into the numbers now. And so in terms of competition, I think it's important to say that the circular economy is not about exclusivity, it's about inclusivity. It's not about competition, it's about collaboration. It's about bringing these forces together to affect real game-changing seismic shifts. So it's a global size and opportunity, and I don't think I have to educate this audience on that. But whether you read Peter Lace's Waste to Wealth, $4.5 trillion opportunity, only 9% of the world is circular. His latest book actually suggests that it's going to be $1 trillion of value creation at stake across the 2020s. T himself is pretty minted. He's worth $2.5 trillion. Good for him. And actually, this market's set to grow by 20 billion in the next 5 years in terms of green tech. But if you look at what consumers are saying, every single segment, Gen Z, millennials, Gen Y, Gen X, boomers, want this. They want sustainability products, but brands can't give it to them because of the archaic nature of their compliance, their technology, and their inability to commercialize. Google uptick of 4,500% in these related search terms, that consumers are driving this drumbeat, but it doesn't exist. It's a huge wasted opportunity on the table that has to encompass the invention and innovation to move things forward. Our commercial model has got kind of 3 elements to it. It has a kind of a partnership fee based on your revenue. So the B2B licensing in terms of enterprise software is fairly low, around sort of £200,000 per client. The clicking on the sort of farm and factory and use and reuse, each of them gives us an additional percent of that particular T-shirt to our revenue model. If they click on all 4, we get 5%. So it's called data-driven attribution modeling. Sorry about the dry chat. But we're looking at an additional 360K per client based on that. But the kicker, and the thing we don't really know how big it's going to be, is the app, because it's an affiliate model like Google, that every time someone goes to like a ThreadUp and then sells the jacket and we take 5% back for that converted transaction, we've got no idea how many clicks and how many items will be added to the wardrobe, and you have a Ted Baker side, and you have a Crew side, and you have a Burberry marketplace, all living within the app with the same experience, where you can chat to your clothes and give them a second life. We've got no idea, but a typical client we're going for, we think we might be able to attract about 450,000 users per client, which generates significant ROI for us and also for the client themselves. So for approximately what we're kind of lowballing as £1 million per client, we're looking at a 15x return on investment for our typical client, which is going to generate 15 million return on investment by the uptick metrics of things like conversion moving forward. In terms of competition, it's really collaborators. So our C module, which is our data analytics portal, these folks are all our partners. We're not going to compete with them. They're going to use our platform to sell to their clients. And in fact, all the LCA guys, that's not our business. They're going to come in and implement the data. In fact, many organizations already have a life cycle assessment provider. On top of that, there's some fantastic innovations coming up, like a product platform called Everything. Again, we would recommend them to our clients to bridge the gaps where we don't want to get involved. The use phase, there's some tremendous work being done with lots of different sort of traceability and transparency tools coming together. And again, we can scale them as an ecosystem as part of our platform. If you don't want to use our technology, no problem. It's a very flexible approach. We can use your provider instead. It's all about the circular big picture whole, because you cannot have circularity with a secular siloed approach. And actually the best examples of the use phase in e-commerce are G-Star Raw, they've done some great factory stuff, and actually Asket as well, done some fantastic stuff on page. But again, these are not competitors, these are potential clients, these are retailers. And whenever a retailer tries to do something in a proprietary way, it's a little bit of a red flag, because they've done it well, but there's certainly a lot more they can do to hit their goals and lift their metrics. And then finally across resale, ThreadUp, and the whole resale market are our partners. We don't want to get involved in their operations. Rental companies like Rental Runway, re-commerce like a Reflaunt, or renewal workshop or repair are again our partners and part of our ecosystem. That again, it's about the collaboration. It's about bringing people together to unify stakeholders, shareholders, and consumers. So instead of like against, it's about who. And Circularity are bringing together a wealth of ecosystem partners to bring this to life, from client side, big consultancy partners, as well as Google themselves. The forecast, I think, that Phil kindly put together, and we decided to go with the lowball forecast, so apologies. It's a cash-generative business. Software margins are like 85%. The use of funds will be split between growth and operationalization. In terms of our balance sheet, we've really lowballed it. And this is based on us only getting 100 customers in the next 7 years, which means we failed completely. But the thing of note is the app revenue in year 7, 52 million. We do expect that to be a proportion bigger than the rest of our business. In terms of COGS and SG&A, it's kind of what you'd expect. But the crucial thing is, even if we fail, because it's proprietary technology, we scaled to 2 billion exit valuation by 2027. And bear in mind, this is just for the apparel cloud, right? We're going to launch other clouds down the line, the timeline. So in 2020, we're going to commercialize by the end of the year and finish off our MVP. But we're also going to launch the FMCG cloud in 2024, maybe late 23. Also the ICT cloud, plastics, oil and gas. Everything has a circular component, and we hope that almost all of you, in fact, absolutely every one of you, will be our partners moving forward in the future. So finally, the ask to bring from development to commercialization is 4.2 million to build our use and reuse applications and bring them to market to start the revolution so we can begin defining a better tomorrow for generations to come, but also begin to pivot back to create the B2B side of our platform, which is all about sustainable designing, 3D sourcing and modeling, connected series of sustainable marketplaces for materials, for ethical producers, for clean energy for manufacturers, right the way through to digital tagging the physical product, so we can have an entire life cycle approach of what's happened to that particular piece. So please do get in touch. I'm excited to be part of this and to include all of you in it moving forward, and can't wait to begin working with you all. Thank you so much.
Thank you very much, Jamie. Unfortunately, we do not have time for any questions, but I am sure Jamie will be very much available to grab outside during the coffee break. So if everyone is back here at 5 minutes to 12. Thank you, everyone. Up next, we have MCPV with CEO Marc Rechter.
There we go. Good morning, everyone. Hope you had a good coffee. There we go. Before I start, I'd like to refer to Dr. Andrew Steer's comments yesterday, which I think were extremely to the point as to where we are today. No longer in an energy transition, but effectively in an energy transformation. That's precisely what MCPV is about. It is about massification of deployment of low-cost clean energy. So I thought that'd be a nice context to start with. And it's about delivering low-cost energy through solar, which is already the lowest cost clean energy technology that we have today in most places, increasingly in most places. And what's interesting in solar is that the pace of change of technology and manufacturing has allowed it to effectively change the energy transition and now transformation. But one of the problems has been, at least from a European and US perspective, that a lot of the value of the solar value chain has gone to Asia, and specifically one specific country who I won't mention because you know which one it is. Now, that is becoming increasingly an issue
when we look at the implementation of our 2030, 2040, 2050 targets in terms of decarbonization. Specifically, as we've seen our over-reliance on the, let's say, supply chain inefficiencies or supply chain risks coming out of China, especially during the COVID times. So, as we identified a number of years ago, it is fundamental to bring back the technology manufacturing that are at the core of the energy transformation into our own markets. And when I say into our own markets, it's basically Europe, the US, the key markets that also have to lead some of the energy transition efforts going forward. And so we've been working on this for the past, well, 12 years. Not MCPV specifically, but generally the energy transition or transformation. And over the past 2 years, we've been putting a lot of our effort into bringing back solar manufacturing to Europe specifically. And what you see on the screen is part of the result that we've achieved, I think, at the political level. And it's a pleasure to be here and discuss with you a little bit what we are doing, what our plans are, and effectively launch a little bit more publicly what we're planning to do over the next decade, helping not only to accelerate the energy transformation, but also capturing some of the value, the jobs, the economies of that enormous change in our society. So I'll take you through a couple of basics, and then we'll go into some of the details around where we are in terms of funding, etc., and the opportunities that brings along. So very briefly, MCPV has as a mission, as a goal, a number of key elements. Primarily, it's looking to address the huge demand, the huge need for low-cost clean energy that is emerging around the world, and specifically looking to do so on the back of solar technology, of PV technology. Unfortunately, PV technology is allowing us to do so, and we'll get into that a little bit later. And specifically, that is allowing us to do so on the basis of so-called heterojunction technology, silicon heterojunction technology. And if you would like to find out more detail, we have our CTO Benjamin here with us today. So anyone that would like to know, deep tech, Ben is here to discuss. And what we're doing is we have designed strategies and technical integration to deliver platform-based heterojunction manufacturing facilities in Europe in a first step, looking at deploying 15 gigawatt production capacity by 2027, 2028. Scaling to that scale is ambitious. It's a challenge. Total PV deployment in Europe this year is about 23 gigawatts, so it gives you a sense of where we want to go. But as you'll see going forward across a couple of these slides, 15 gigawatts in 2030 is not that much. So this is our goal, and we're looking to do so and achieve that critical mass in order to achieve sustainable, competitive LCOE, as we call it, levelized cost of electricity. So I've already told you a little bit about the background. The shift in technology that's allowing us to do this, because when you first speak to a lot of people, you say, well, we're going to build manufacturing plants, PV manufacturing plants in Europe. They look at you and say, are you crazy? Because, this is China, right? The point is that China has invested over the past 10, 15 years, hundreds of billions in so-called PERC technology. And PERC technology is what we all know, is what we see in the roofs, what we see in the fields, et cetera. And PERC technology is great. It's allowed us to go very low cost, et cetera, et cetera. But it also has a downside, and that is the fact that it has an absolute theoretical maximum efficiency of around 23.5%. And it's currently at around 22.5%, so it's just 1% left. And after that, basically, that's the end of PERC. Why? Because competitiveness of solar only comes out of two parameters. One is cost compression, and cost compression you achieve through massification and scale efficiencies. And the other one is efficiencies. So when your efficiency ends, basically the only thing you have left is to scale more, but at some point your scale doesn't matter anymore, and then in China scale really doesn't matter that much anymore. So it is time to jump to a next generation of manufacturing technology, which is heterojunction technology, which is going to take us from 23.5%, 24% of efficiency today, all the way up to 35% over the next 10 to 15 years. Now the good thing is, and the opportunity that we have in Europe and the US as well, is the fact that China has invested these hundreds of billions into PERC technology, and they're not able to shift to heterojunction within the next 5 years because it would cannibalize their existing investments. So they first have to amortize these hundreds of billions of investments in PERC before they're able to shift to heterojunction. And that is the big, let's say, framework or opportunity framework that we have in Europe and the US right now. It's basically a 5-year time horizon in which we need to build our industrial skill. In addition to that, as you'll see going forward, we have an exponential market growth. So what we have today in terms of solar, excuse me, is relatively very little to the amount of solar PV deployment that we need to do in order to get to our climate targets. So we have a huge market growth, and so demand is the least of our worries. In addition to that, of course, we have strong policies. We have the European Green Deal, we have the industrial clean hydrogen strategies setting in now. We have the US also following, luckily now with Biden. Lots of public money available to, let's say, support the infrastructures that are necessary to go through this transformation. And so I would say that all of the parameters are green lights, so to speak. In addition to that, and competitively speaking, if we look at the fact of this kind of 90 to 95% cost compression that we saw in PV over the past 15 years, the cost of transportation from China to Europe hasn't really decreased. So what we see today is that cost of transportation is about 10 to 15% of your total price of a module. And so producing closer to your market is becoming an increasingly important competitive factor, and that's also what we're looking to do. In addition to, of course, security of supply and the energy independence that I think I mentioned earlier on, which are strong drivers. So how are we going to do this? Well, we've had the very fortunate situation that over the past 12 years or so, we've been able to build a global network around innovation, around solar, around, let's say, integration of energy systems, and learning what would be the future of the energy business models, so to speak, the decentralized energy business models. And so we were able to put together around the objectives of MCPV and around the ambition of MCPV, an absolutely fantastic team of international experts from across the value chain. That includes some of the names that you see here, including, again, Benjamin Strawn, that's here, our CTO, who was the head of R&D at Meyer Burger, who effectively built the machines that produce heterojunction cells. Dr. Bo Lee, who effectively built and managed and operated a heterojunction facility for 5 years. Professor Eike Weber, former head of Fraunhofer Institute of Solar Energy. And Natalie Samovich is here with us as well, leading our digital side of things, because Industry 4.0 and 5.0 are core parts of our industrial strategy. The integrated model that we have developed looks not only at excellence in manufacturing and establishing scale and technology advantages at the cell and module level. It also looks very much at making sure that we can integrate with our ecosystem, with the rest of the supply chain up and down, basically because we need to jointly with our supplier ecosystem build or rebuild the market in Europe and get the scale so that we can build sustainable competitivity across the industry. A little bit about the technology for those of you who are not familiar with solar. So as I mentioned earlier on, PERC technology is the technology that we are very familiar with in terms of solar panels, solar modules. We've seen them all over the place, but like I said, they have this limitation in terms of efficiency. So this table on the left that you see demonstrates some of the key parameters that allow us to better understand how heterojunction will be outperforming in terms of efficiency PERC and also TOPCon. TOPCon is PERC plus a little bit of extra technology that kind of is an add-on, but not able to compete on the efficiency level with heterojunction. And what this does to us, basically, is that the differential in efficiency that we can get in our product, even though our product, especially in the beginning, will be slightly more expensive than PERC, what we have to compete on is the levelized cost of electricity. And so with this differential in efficiency, we effectively get to a better levelized cost of electricity. And this is exactly what our clients need. The price per watt is not as relevant as the price per kilowatt hour, so to speak. So it's the yield on the solar parks that really matters. It's not so much the price per watt. Okay? Beyond that, I think I mentioned earlier on, we have a lot of upside potential because the heterojunction cell is a technology that fits very well in terms of what we call tandem layering, tandem cells. So we can layer additional chemistries on top of the base cell going forward to drive the efficiencies higher. And that includes probably from 2028, 29 onwards, a layer of perovskite chemistry. And with that, we will be looking to reach the 30 to 35% efficiency at the cell level by well over the next 10 to 15 years. So we have a very clear roadmap in terms of continued competitivity, scale, and also market leadership, I would say, if we manage to scale sufficiently. The product is another interesting point because what we've seen is that solar cells and solar modules have become very much commoditized over the past 10 years due to the approach that mostly the Chinese manufacturers have taken. Of course, nothing wrong with that. It's allowed us to go very low price. It's allowed us to go, for PV to become the lowest cost technology in many regions. However, it is now time, and we have the possibility to tweak this technology at the cell level, at the module level, and tweak it to the needs of our clients. And our clients are the big IPPs, the EPCs, the large-scale deployers of solar PV modules. So we're working with these companies to really understand what their goals are. What are they trying to achieve with the deployment of their modules? Are they trying to produce in a specific location for the production of green hydrogen? Are they looking to achieve the most hours in a day with trackers to access single acre trackers, etc.? So all of these components matter when it comes to, let's say, tweaking the design of the cell and the module. And in doing so, we can actually offer our clients added value, and through the added value, of course, a better economics both for the clients, for ourselves, and for our value chain. In terms of market, I touched on it earlier, but just to remind everyone what's happening. We are seeing an enormous electrification push across the world as we decarbonize. The basic mantra is electrify everything that you can electrify, because this is the most efficient way to use our renewable energy. And it's happening across many sectors. It's happening in mobility, for sure. There's a huge push coming along in terms of green hydrogen. It will need massive amounts of clean electricity, and that clean electricity will come mainly from solar and wind. Excuse me. And then, on top of that, of course, we have the fact that the levelized cost of electricity of solar continues to go down, meaning that it will increasingly be the cheapest form of electricity generation anywhere in the world. It has a lot of versatility. You can deploy it in many different ways. And we are seeing some very strong policy support trends underlying it. So again, all signals are green in that sense. In terms of market, there are several forecasts, and these are some of the forecasts of the leading agencies around the world. But basically what we can say is that the solar PV market today is in a similar time frame as the car industry was back in the 1920s, approximately. At least that's what Professor Weber likes to compare it with. In terms of industrialization, in terms of scaling, you can compare the solar industry today where the car industry was back in the 1920s. So we have a huge growth curve ahead of us. And again, this is a huge opportunity economically. It's a huge opportunity for jobs. It's a huge opportunity for, let's say, economics, apart from decarbonization. And some of the graphs on the right show you, let's say, the forecast growth and the component of solar PV within the total energy mix going forward to 2050, which is enormous. In terms of our targets, with our 15 gigawatt target for 27-28, we're looking to achieve a total market share of around 2.5%, considering that by 2030, the annual photovoltaic market is estimated to be around 600 gigawatts, so 600 gigawatts of additional capacity to be deployed every year, and which would be around a 5% market share of the total global utility market for PV. So this is ambitious, but definitely, again, doable. Our market segments, our target markets, are IPPs and EPCs and large corporates, and we are very fortunate because Europe has some of the globally leading IPPs and EPCs. And we've been talking extensively to these companies, and they're telling us, look, we really want to have a European supply chain manufacturing cells and modules, because we are increasingly feeling the squeeze out of China, whether it's geopolitical or whether it's price-wise, whether it's instability. They have to pay 6 months up front in cash and then wait and see if they get delivered, right? Quality is an issue. Quality control in China is challenging. So there's many drivers that basically are let's say, motivating our client base to work with us very closely and strategically in building this and building capacity fast. So our plan is to, and we're already working on that implementation, deploy initially in Europe with a focus on centralized cell manufacturing in Germany. And this is particularly so because Germany has a strong history in PV cell manufacturing, so there's a lot of skilled labor still available. There are a number of research institutes that we're very close to that have a lot of knowledge, know-how, and capacity to help us further develop going forward. 1 minute, and I need to accelerate. So cell manufacturing centralized in Germany, and module manufacturing, let's say, decentralized close to our target markets, which are the sunny, hot climates in Europe and later on abroad, where we've had significant interest from the Middle East, for instance, and the Americas, also in deploying manufacturing sites. So speeding up a little bit, As I mentioned earlier on, we have an exceptionally strong team with all the capacities and capabilities and experience to deliver on this project. The project effectively does not have a significant technology risk. It is more a type of construction risk that I would describe it as. Strong relationships across the industry globally, as well as at the policy level, where we're very involved in advising the Commission and member state governments on their energy policies, and specifically also the solar and green hydrogen policies, and very deep roots across the markets and technology ecosystem. To conclude, just very briefly, we've been working over the past 1.5 to 2 years to design and prepare all of this, get the core team together, work with the policy makers on supporting this re-emergence of solar manufacturing in Europe. We are now moving towards the implementation of our first pilot line, which is about a 60 million effort in 2022. We'll be up and running in early 2023. And we will then be expanding with a 3 gigawatt per year ramp up every year after that to reach our 15 gigawatts around about 2027, 28.
I am very sorry, Marc.
I have to conclude. Thank you very much then. I'm sorry I'm a little bit too slow, but anyone who'd like to have a discussion about this, I mean, we're going to be here until the end of the day. So thank you very much. Thanks.
Please do grab Marc if you have any questions after this. Next up, we have Carbon GeoCapture with President and CEO John Pope.
Good afternoon. I'm here to tell you about a new approach to carbon management that we've been working on for the last 20 years. Many people are starting to realize that on our current course of action, we are not going to avoid the most catastrophic aspects of climate change through emissions reductions only. In fact, even if we take dramatic immediate action around emissions reductions and the energy transformation, we are still not going to avoid those impacts. We need time, is the reality. And we need time to reduce our carbon emissions. We need time to remove past emissions from the atmosphere. Carbon capture and storage is the way that we're going to be able to do this. The need for carbon capture and storage, based on IPCC's, the UN Working Group's projections, is that to hold at a 2 degrees Celsius level, we need to sequester about 5 gigatons per year of CO2 every year between now and 2050. In order to hold at 1.5 degrees Celsius, we need to sequester up to 12 gigatons of CO2. Excuse me. Last year, we sequestered 0.04 gigatons. We have a problem. We're behind. And this work is not in replacement for emissions reductions. These estimates assume that the emission reductions do continue at pace and accelerate now. Unfortunately, practical options for achieving these goals don't exist at present. This graph shows the primary carbon capture and sequestration methods that have existed over the last 5 years. These are projected out at 2050 by a group headed by a team at Oxford. What this shows is, given the technical and economic headwinds that each one of these methods faces, the level of sequestration that that group expects each method will be able to achieve by 2050. As you can see, these are not ready right now. And even by 2050, they will not be sufficient capacity to address the need. For the last 20 years, we've been working on a new method of sequestering CO2 into unconventional rocks down deep in the earth. And we believe, now that we've been able to unlock the capacity of these rocks, we believe that these rocks will do represent an opportunity to sequester massive amounts of CO2 very quickly. And based on current economics, not future economics, we believe we can do this right now. And not only do we believe that these rocks will hold the amount of CO2 that we need to get rid of this year and next year and for the next 30 years, but estimates suggest that these rocks can hold those levels, that these rocks have the capacity to take that amount of CO2 for the next 450 years. And so again, this solution, if it becomes realized, may be an answer to the challenge that's facing us. All right, so we think that this merits a close look, and that's what we've been doing for the last 20 years. Let me tell you a little bit about what this approach looks like, and before I tell you why we've been pursuing it. Conventional CCS, geologic CCS, targets deep rocks that are sandstones or salt domes. These are 5,000 to 10,000 feet down in the ground. Unconventional rocks are typically 300 meters to 600 meters deep. Conventional rocks accept CO2 like you blow up a balloon. You take CO2 under high pressure, you push it down into the ground, you blow up a balloon deep in the ground, and the rock that's above the balloon is what holds it in. And so it's expensive. There's some risk associated with making sure that the rock will hold it, which adds a lot of lead time to the effort. Unconventional rocks, in contrast, are shallow at low pressure. They're more like a sponge. If you show CO2 to these rocks, they soak it up. They like the CO2, and the CO2 likes to be there. And as a result, they have a different profile when it comes to permanence and when it comes to geologic risk due to earthquakes and other things that might happen in the future. These unconventional rocks have held CO2 for tens of thousands of years. Mother Nature has been doing this quietly for a long time. Others have tried to unlock unconventional rocks to accept CO2 that's injected into them. We're the first that have figured out how to do it. And so before I tell you how we've done that, let me tell you why. And of course, the number one key parameter is cost. Because these rocks are available to us at lower pressures and at lower concentrations of CO2, we have a dramatic, these rocks present a dramatic opportunity to do CCS at a lower cost. And not just on the sequestration side, but also on the capture side, where we do not have to clean up the CO2 to a high purity, we do not have to condense it to a liquid. And so if you spend a lot of time during a pandemic shutdown doing models like we did, what you find is that is you can easily estimate that this approach, the approach we're taking, is a quarter to a third of the cost of traditional CCS. Conventional CCS, which is at $80 to $120 per ton. The unconventional approach appears to offer an opportunity to sequester CO2 all in, capture to sequestration at $20 to $40 per ton, which, as you may know, is below the prices that are being paid in the EU for carbon right now, as well as below the Section 45 tax credits that are available in the US currently. The second key parameter is location. Unconventional rocks are coals and shales, primarily, and they underlie 75% of the world's landmass. Not only are they available in countries around the world, offering a range of jurisdictional, regulatory, and sovereign risk opportunities, but also they're typically located very close to point sources, because in the past we located point sources like power plants, steel mills, cement plants, close to these rocks because we use them as fuel. And so, this approach offers a significant advantage in terms of attainability, in terms of project profile, in terms of project startup. These are lower intensity, more distributed rocks, sinks, than traditional CCS sinks. And so as a result, this unconventional approach is more of a scaled manufacturing approach where there's low unit cost, a low entry point from a cost and a project size standpoint, but also a high scalability as compared to other approaches. So think this is more like a McDonald's approach to CCS versus a NASA approach. The third key advantage is that the process is verifiable. And this is because we've spent $35 million and 20 years developing the sensors that are required to monitor the process and verify where the CO2 resides when the process is complete. And this is actually a good opportunity for me to pause for a minute and explain how the process works. It's very simple in basic concept. What we do is, for example, for a coal seam that's unminable, that's deep in the ground that no one will ever touch, we go in, we pull the water out of the coal seam, which naturally occurs in the coal seam. We bring it to the surface, we dissolve CO2 in the water, we drop the water back down into the coal seam, and we flow it through the seam. It turns out that coal is a nanoporous structure that really, really likes CO2. So as the water and CO2 flow through it, the coal seam sponge soaks the CO2 out of the water. We then lift the water back to the surface and do it again. So we watch this entire process with our sensors, with our proprietary sensors. When it's completed, we watch the water pressure that's on top of the CO2 long-term using long-term monitoring pressure sensors that we are the leaders in the world on deploying. So it's safe, it's verifiable, easily monitored, easily controlled. Everything I just described is the opposite of how Mother Nature flows water and gas from coal seams right now. And so it's also very well understood in reverse. And the last primary advantage of this approach is if you take all of the things I've just told you and you bundle that into an economic business model, it turns out that this approach appears to have a profitable business model available to it right now. So this, we believe that we can achieve at least $34 per ton in revenue from a combination of tax credits, carbon prices, and voluntary offsets, probably as much as twice that amount over time. And we also believe, based on very, very detailed models and work that we've done, that by paying $10 for capture, $1.20 for transport, and $16 for sequestration, we can leave a profit for this business. Achieving these economics, demonstrating these economics is what we're doing next. If you want to think about what this looks like then, long-term, at scale, that's what the right side of this slide shows as examples. If you spend $65 million, you can sequester 1 million tons per year with this method for 30 years with an IRR of 11%. If your appetite is larger and you'd like to take care of 5 gigatons per year, that's about $134 billion with a 26% IRR. So again, this, while these numbers are large, 5 gigatons is the entire world's budget for CCS in order to achieve a 2 degrees Celsius outcome. All right, so I'm the CEO of this business. I've been working on this since '99, quietly in the background behind some 10 other businesses that I've started. Most of the businesses, some of the businesses I've started have been directed at supporting this one. The sensing business that we developed around our proprietary sensors to support this business has grown quite large. It received President Obama's e-export award for taking its technology overseas. It was 88 on the Inc. 500 list of fastest growing private companies in the U.S. My background I have a PhD in nanotechnology, physical chemistry, and I've started businesses since '98 that are focused on sustainability around batteries, fuel cells, reclaimed building materials, and big data for energy sustainability. Wade Bard is a reservoir engineer who came out of retirement in order to work with me on this project about 4 years ago. Wade has worked all over the world with a major focus on carbon management, water and carbon dioxide floods in places like Australia and Indonesia. Chris Walker is one of the people that's been at the center of climate change mitigation efforts for the last 20 years. He was the director of North America for the World Business Council on Sustainable Development. He also founded and drove Climate Week in New York City. Chris Verone, Chris, if you don't mind raising your hand so people can see where you are. He's here with me today. Chris, likewise, has been very, very focused on doing everything he can to mitigate climate change. And that includes being a consultant and a banker to more than 50 clean tech companies over the last 10 years. Prior to that, he was a senior executive at Vestas Wind Systems. Jay Sjogren is a friend of mine who's been working with me ad hoc on this business concept for about 20 years. He was a lead author for the UN's IPCC group. He was part of the group that received the Nobel Prize for that work. He also has advised President Clinton, King Gustav, and currently the Wyoming state governor on climate change issues. Marc Northrum just retired after a distinguished career as one of the energy industry's top carbon management gurus. And Dr. Northrum also, as his last thing before he retired, he founded and drove the key Clean Energy Research Institute, one of the key ones in the US. And then Pat Galvin is not only on our advisory board as a technical entrepreneur who's worked all around the world in environmental and energy projects, but he also is a lead technical investor in our round. And he's available to talk with people about what's happening with our technology and the promise that it shows. All right, so all of these people are involved because not only are they super passionate about doing what they can to mitigate climate change, but also because they believe that this approach offers us the best opportunity to do so. What we're doing right now is that we are in the process of demonstrating the economics of this approach in the field, and we'll be doing that starting in November in Northeast Wyoming. I've put essentially all of my personal assets and net worth into this business repeatedly over the last 20 years. Many of the people on the last slide have invested as well. Right now we're looking for people that want to join us in giving this approach a good shot. And what that looks like is a small common stock, around $2.5 million US, $15,000 minimum, at a $20 million pre-money value. And the use of funds is, again, to do the demonstration, to do the work around the demonstration that allows us to get the methodology certified with a standards body, and that it positions us for what we think is next, which is profitable at-scale growth of this approach using profitable, positive IRR, SPVs and JVs. So thanks for your attention. I'd be happy to answer any questions that you might have.
Thank you very much, John. Again, if anyone has questions, please do feel free to, feel free, sir.
Great presentation, and I wish you all the best. The question I have is, when your suppliers of the CO2 from whatever source understand the economics and the profitability of the company, do you have long-term off-takes for the CO2, or how do you protect yourself from the greed factor of them wanting to encroach on your margins?
Yeah, no, I appreciate the good wishes. There's two phases of this business that we're focused on. The first is buying all of us time to deal with emissions reductions. And so for that phase, we'll be dealing with CO2 offtake from power plants, from industrial sources and other places. The question that you're asking is one that's largely unexamined in the world so far. No one has had this capability, so no one's been able to go through that negotiation with those point sources and determine where the splits will be on the margins. We do believe, though, that as a unique solution with many point sources out in the world, that we'll have a leverage point in that negotiation. We'll be able to protect ourselves from those risks. There's a more subtle question there also, though, which is that as an acquisition target, that would be another way to co-opt the focus of the business on climate change and refocus it around propping up point sources that are looking for that advantage. And in general, again, we've been doing this for a long time. We're very mission focused. This is not a flip for us. This is something that we're very focused on using to achieve the climate change goals. And actually, I appreciate you asking the question, because that reminded me that the second phase. I want to share with you the second phase of the business here. I showed you the economics for the emissions reduction approach, which is using point sources. We are currently also working up similar economic models for